So hello everyone. In the previous video we have seen how to solve permutation in string task, and there I have noticed and said that actually there is another option how we can solve this task using ASCII codes. So to make the solution a little bit better, a little bit more optimal. And I have a small short video on the channel. I think I will leave a link to it down on the description, so you can see visualization of this algorithm. In general, it will remain the same like in the previous video, but the difference will be that in that case we will not use map to store characters and frequencies, but we will use arrays and ASCII codes. So probably right now nothing is clear, so better let's go and check the solution and the code. So let's move further. So let's copy the signature because the method will remain approximately the same, but we will make a small modification. Okay, now let's create two variables, I think, where we will store length of the first string and the second string. So let's name it s1 length is equal to s1 length, and the second variable s2 length, which is equal to s2 length. Okay. Now let's put a condition that we want that first string to be longest. Change the name of the method. So we want s1 length. So if it's higher than s2 length, then let's return true, false. Let's say, or maybe a description which will say that we want our first argument to be less than the second. Yeah, so the string which we are searching substring, we need to put like first argument, and where we are searching should be the second argument. Now let's create two arrays. Now I explain for what. So we will have, let's say, s1 array, which is equal to new int 128 and int s2 array is equal to new int 128. So for what we are doing this, so actually every character has a number in ASCII code, and in total, as far as I remember, characters in uppercase and lowercase, some other characters are included in this diapason from, if I don't make any mistakes, from 1 to 128 probably. And when we will iterate through our strings, we will place the character in the index which corresponds to its ASCII code, and the value will be the frequency of that character in our string. So I hope it's clear. Now let's use a for loop in order to iterate through our first string. So let's create int I is equal to 0, then I is less than n, and then I plus plus. Now let's actually, here is a small mistake. S1 length, yeah. So like in previous video, I want to initialize, in that case not a map but an array, where I will store in where index of the, let's say, box of the array will be the ASCII code of the character, and the value, how I already said, will be the frequency of that character in this string. So let's do this. So S1 array, and we need S1 char at I, so and plus plus. So let's say if A, for example, has ASCII code 1, it will be positioned in bucket with index 1, and and value will be, let's say, 1 in case if we have only one A character in our S1 string. And let's start to iterate through our second string also in this for, if we already started. And here we will have S2 char at I plus plus. And now we can check, for example, if these arrays are equal. So S1 array is equal to S2 array, then it means that we have found a substring in our string, and we can return true. In our case, if we haven't found in the first, for example, 2 iterations the result, then we need to continue to iterate through our second string. So let's do this. Let's create another for loop. Here we will initialize int e, which is equal I to 0, and I should iterate S1 length minus S2 length. Yes, I plus plus. Why so? Because we already iterate from 0 to less than S1 length, so we need to iterate more, to continue to iterate, and we need to iterate S1 length minus S2 length. Probably here is a small mistake, I think. Here should be something like this: S2 length, S1 length. Yes, now it's correct. Okay, so let me check if I don't have any mistakes. I think it's okay, so we can continue. Okay, and in that case, let's move the right pointer to the right and left pointer also to the right. But like in the previous example, we will use our array, and we need to decrease the frequency of element which we'll remove from our window, and to increase the frequency of the next element which enters in our window. So let's do this. Let's call our S2 array and word S2 char at I minus minus, okay, and S2 array S2 char at I plus plus s1 length. Plus. Yes. Why so? Because, like I've already mentioned, we already iterate from 0 to s1 length. So we will start, the right pointer will start from the next element for which we haven't iterated yet, and it will be s1 length. And we need to increase the frequency when this element will enter to our window. And now we can return, actually we can check if after we moved our window, we can check if s2 array is equal to s1 array. And let's check if this method is working. So we have a, b, here we don't have a, b, so it should be false. Okay, now let's try to add b here. Okay, it should be true. And now let's change the permutation to be a. It's also true. Cool, so method looks to work. Now let's go back and analyze the solution. So what have changed in our complexities? So the time complexity have changed. We have O(n) time complexity. Arrays equals method on two fixed size arrays of 128 is considered O(1) time complexity because it doesn't depend on input data. So the whole loop is O(n) complexity, and the space complexity is O(1) because we have two fixed size arrays of 128. So that's the optimized solution. I hope you understood this task and enjoyed this video. So we will see in the next ones. Bye. Watching the video, I have noticed that I have committed a small mistake, and this mistake is here because I compare two arrays not inside for loop, but actually we need to do this inside this loop because when we change our window, we will start the loop again, and we need to check if something have changed, if now our arrays are equal. So that's it. Thanks again, and bye.